Hi, welcome to the presentation on out-of-device privacy unveiled, designing and validating the out-of-device privacy scale. I'm Habiba Farzand, and let's start. When using a personal computing device, such as a smartphone, threats to information privacy are not only on the device itself, for example, a GUI confusion attack, but threats could also originate from external factors surrounding us. Everyday scenarios such as withdrawing cash at an ATM and being recorded by CCTV, or traveling on a bus and being shoulder surfed, make the user's data susceptible to attacks in the physical world. Looking into literature, we come across several privacy scales, for example, the IUIPC. However, they are limited to specific scopes. For example, the IUIPC scale precisely measures online information privacy concerns. On the contrary, we do not have a standard scale to measure users' privacy towards threats in the physical world. For example, how users view these threats in the physical world, how much concern they get, how much importance they attribute to such similar threats. These all things need to be assessed in a systematic way. Looking into why do we need to know such information is that there are differences in individual perceptions and needs. Second, privacy invasions in the physical world negatively impact users. They cause awkwardness, discomfort, and have resulted in interaction time wastage with the device. Furthermore, negative impact and perception varies cross-culturally. Lastly, but not the least, users are unaware of the privacy invasions, and people don't always envisage surrounding technologies in the context of privacy invasion. In this paper, we make two contributions. Number one, we propose a definition for out-of-device privacy, which is defined as the importance a person attributes to protecting personal information from out-of-device threats in the physical world. Second, we present an 18-item scale instrument to measure the importance a person attributes to protecting personal information from out-of-device threats in the physical world. The out-of-device privacy scale provides a lightweight method for security and privacy researchers and technology developers to evaluate and protect users' behavior to protect the user's data from out-of-device privacy threats in the physical world. Towards this goal, we implemented a three-stage methodology. Stage 1, item development. Stage 2, developing the scale. And Stage 3, final scale validation. I will now walk you through towards the steps in Stage 1, which is the item development. The first step was the identification of the construct. Our goal was to develop a scale that assesses out-of-device privacy. To identify the construct and develop a precise definition using simplistic terms, one researcher first defined out-of-device privacy. Next, two researchers discussed the definition and iteratively refined it in multiple rounds. The definition was then finalized, which we present as the importance a person attributes to protecting personal information from out-of-device threats in the physical world. The next step was to generate an initial item pool. For this, we followed three approaches. Number one, literature-based. We reviewed existing literature to understand people's experiences and concerns regarding out-of-device threats in the physical world. Second, fellow researchers at our institute with expertise in security and privacy and HCI participated in a short survey that inquired how they would ask people about out-of-device threats in the physical world. And lastly, two authors individually created new items related to the construct definition. After generating an initial pool of items, the items were then reviewed by a psychology expert, specifically focusing 4 key points. Number 1, identification of duplicates or similar worded items. 2, verification of item relevance to the construct definition. 3, checking of subjective interpretation. And lastly, inspection of linguistic accuracy. The items were then pilot tested with 50 participants to check for understanding of statements and variability in responses. After reviewing the statements, we then proceeded towards developing the scale and identifying the underlying factor structure. In stage 2, we collected data from 400 participants and performed initial data analysis, which included checking of attention checks, descriptive statistics, and KMO-MSA. We then proceeded to identify the factor structure using 4 methods. Number 1, multi-factor solution. Number 2, scree plot inspection. Number 3, factor correlations. And lastly, reliability. In the light of all these methods, a single factor solution was finalized. We then proceeded towards stage 3, which is the final scale validation. In stage 3, we collected data from 1,000 participants and performed initial data analysis including attention checks and sampling adequacy using KMO-MSA test. We then proceeded to perform confirmatory factor analysis and checked for various fit indices such as CFI, TLI, and RMSEA. We then performed tests of reliability, which shows internal consistency. This was done using the reliability test using convex alpha and composite reliability. The proposed scale was then compared with already existing privacy scales that measure online information privacy concerns. This was done to ensure that the proposed scale indeed measures a new construct and something which is not captured already in the existing privacy scales. In light of all these results, an 18-item out-of-device privacy scale was finalized. The out-of-device privacy scale can serve multiple purposes. For example, it can be used to measure out-of-device privacy, which would provide insights into the user privacy profile, which could then be used to inform the design of protection mechanisms. It could also be used in combination with other privacy scales such as the IUIPC, which can help in constructing a privacy profile of user that explains their perceptions of privacy in the online and physical world. It could also be used to measure the privacy culture, which could then be incorporated into the tech devices. Lastly, it could also be advantageous in designing protection methods against threats in the physical world, such as shoulder surfing. If you would like to know more about the results, please read our full paper. Many thanks for your attention.